Hey students, in this video we're going to go through section 7.5, which is about surface area of prisms. Today's learning target is I can represent prisms using nets and use nets to find surface areas of prisms. So first let's talk about our two vocab words. The first is surface area of a solid. Surface area of a solid is the sum of areas of all of the faces. So that means we are going to take the area of every single face. For example, if this was my solid, the faces are all the flat surfaces, right? So I'd be taking the area of every single flat surface. And sum means that I'm adding them all together. So let's put a plus sign above there so we know that this means I find the area of every single face, every flat surface, and add them all together. Our second word is a net, a two-dimensional representation of a solid. So this solid here that I was just showing you, imagine that it was a box you got in the mail and you took a box cutter to cut open the box and it folded flat like this. This flat thing is called a net. It's a 2D representation of a 3D object. And this can help us find surface area because it a little more clearly shows all of the different faces. So we're going to jump into example 1 where we're going to find the surface area of this rectangular prism. So here's the rectangular prism. Here's the net, the 2D representation of it. So this is showing us all of the faces, the top, the bottom, front, back, side, and side, and it has all our measurements labeled as well. So this is going to help us find the area of each of the faces, top, bottom, front, back, side, side, and then add them all together. So I'm going to go ahead and start with the top. I'm going to color it in pink so you can see which one I'm working with. The top is a rectangle, and the area of a rectangle is its length times its width. The length and width of this rectangle are 7 and 4. So 7 times 4, I get 28. That's the area of the top. Now, in a rectangular prism, the top and the bottom have exactly the same area. So I'm going to color the bottom in the same color because I know that its area is going to be exactly the same. It also has a length and width of 7 and 4 to give me an area of 28. And now I'm going to go ahead and actually write a little note to myself right here. I'm going to write same area so that I know in every rectangular prism, the area of the top and the bottom are going to be exactly the same. Next, I'm going to do the area of the front. So I'm going to color the front in a different color, purple. The front is again a rectangle. It has a length and width of 7 and 3. So 7 times 3, it has an area of 21. In a rectangular prism, the front and the back have the exact same area. The back also has a length and width of 7 and 3, so it also has an area of 21. So not only do the top and the bottom have the same area, so do the front and the back. And let's write a note about that as well. Now the last two faces are each of the sides, and you guessed it, the sides are going to have the exact same area as well. So I'm coloring them in the same color. Now this one, you may have a more difficult time deciding on its length and its width because you can see its length is 4 inches, but you may wonder, what's the width? It's not labeled there. Well, remember, in a rectangle, opposite sides are the same. So if this side is 3, so is this side. So its length and width are 4 and 3. So 4 times 3, I get 12. Again, the other side will be the same. 4 times 3 to give me 12. And let's not forget to include our note that these have the same area. So in a rectangular prism, the top and bottom have the same area, the front and back have the same area, as do the sides. Now to get the surface area, I'm supposed to find the sum of all of these areas. That means I'm going to add them all up. So if I were to take my calculator and punch in all these numbers, add them all up together, I would end up with an area of 122 inches squared. Surface area is a type of area, so we still need to label it with its units, inches squared. So the surface area is getting the area of all the faces and adding them all together. We're now going to go ahead and try that in another example where we're not given a net. So what do we do if we don't have a net? Well, it's kind of difficult to draw a net, but you could do that. But what else could you do instead? I'm going to show you. So I'm going to pick the face that jumps out at me the first, which to me is the front. The front's the one I notice first. So I'm going to go ahead and color in the front in pink. The front is a rectangle, and this rectangle's length and width are 9 and 5. So I'm going to multiply 9 by 5, 9 times 5, to get 45 as the area of the front. Now remember earlier we said the area of the front will always be the same as the back. So I don't even need to think about how to get the area of the back. I know it's going to be the same. It's also going to be 45. Next, I'm going to work on the top because that's the one that I see next is the top. So I'm going to color the top in a different color, in red, and think about the area of the top. Now this is again a rectangle. Its length and width you may not notice at first because there are no labels directly on either of these lines. But remember, in a rectangle, opposite sides are equal. So if this side is 6, this is 6, the length is 6. If this side is 9, this side is 9, the width is 9, 6 and 9. So I'm going to multiply 6 times 9 to get this area of 54. Now remember earlier we said the top and the bottom always have the same area in a rectangular prism. So the bottom, I don't even need to do any work. I know it's also going to have an area of 54. Last but not least are the area of the sides. And like we learned earlier, the sides are going to have the exact same area. So let's focus on the one that's a little more visible right there. Again, another rectangle. What are its length and width? Well, I can see its length is 6, but you may wonder, what is its width? This side is not labeled. Well, remember, in a rectangle, opposite sides are equal. So if this side is 5, so is this. 6 and 5 are my length and width. So I'm actually going to write the sides over here since I'm running out of room. 6 times 5, I get 30. And again, the two sides are going to be the exact same, so the other side is 30 as well. So I have all my areas, front, back the same, top, bottom the same, side, side the same. To get the surface area, I now need to find the sum of all of these. I need to add them all together. So I'm just going to put a little plus so I know I'm adding them all together. And I would get 258. Don't forget to label it with your units squared, meters squared. Okay, next we're going to move on to a different type of prism. This is a triangular prism. So instead of having rectangle bases, it has triangle bases. Here is an example of a triangular prism right here. We can see it has a triangle there and a triangle on the other side, and they are connected by rectangles. There are 3 of them. So the first example we're going to work on, we are given the net. We unfolded this, created the net so we can more easily see all of the faces. So I'm going to start by working with the front and the back, those 2 triangles. The reason I'm starting with those is because in a triangular prism, because the bases are triangles and the bases have to be identical, those 2 triangles are going to have the same area. Let's actually write a note so we remember that. 2 triangles have the same area. Now, the other faces, like the side, bottom side, those may or may not have the same area, but the 2 that for sure will are the 2 triangles. So I'm going to start with those. Now, to me, it's a little easier to see the measurements on the back triangle, so that's where I'm going to look to find my measurements. Remember, a right angle is always right because it shows the base and height. The 2 sides touching the right angle, 5 and 12, those are my base and my height. For a triangle, I not only do base times height, I also divide that by 2. So for each of these triangles, front and back, I'm doing base times height, 5 times 12, divided by 2. And if I were to punch that in a calculator, I would find out that the area of the front and the back are 30 each. Again, those are always going to be the same, the 2 triangles. Now I can work on these 3 rectangles, side, bottom, side. Doesn't matter which one you want to do first. I'm going to start over here with this side. That side is a rectangle. Its length and width are 5 and 8. So I'm going to do 5 times 8 to get an area of 40. I'm now going to work on the other side over here. Okay, again, even though it's called side, it's not necessarily going to be the same. In a triangular prism, the only 2 that are for sure the same are the triangles. This side has a length of 13, and you may say, well, the width's not labeled. But remember, in a rectangle, opposite sides are equal. So if this side is 8, that means this side is 8. If this side is 8, that means this side is 8. So 13 and 8, those are my length and width. 13 times 8, I get 104. And then the final face is the bottom. Again, another rectangle. Its length and width are 12 here. And then while this side is not labeled, we can look across and see that it should be 8. 12 and 8 for the bottom. 12 times 8 is 96. So I have the areas of all of my faces. Again, the only two that are for sure the same are the triangles. Now I need to find the sum of them to get my surface area. I need to add them all up. If I took a calculator and added all of those up, I would end up with 300 centimeters squared. Remember, it's surface area. We need to label it with units squared. Okay, now we're going to go over this very last one here. This is where we're no longer going to have a net. We're just going to be looking at our figure and finding the area of each of the faces without a net. So I picked the one that jumps out at me first, which is the front. So I'm going to color the front in pink. The front is a triangle, so its area is going to be base times height divided by 2. Well, what are its base and height? Remember, a right angle is always right because it shows the base and height. Here's the right angle, base on the bottom there, and height going up and down. 16 and 6. So I'm going to do 16 times 6 divided by 2. And if I were to type that in a calculator, I would get an area of 48. Now the front is a triangle. Remember, the two triangles will be the same. So where's the other triangle? That would be at the back. So I know the other triangle, the back, will have the same area of 48. Again, those are the only two that for sure have the same area, the front and the back. Next, I'm going to pick one of the sides, one of the rectangles to deal with. I'm going to choose this one because it jumps out at me right away. Here's my rectangle. Its length and width are going to be 10 and 9. So to get its area, I'm going to do 10 times 9, which is 90. Okay, now that's one side. Next, I'm going to do the bottom because I feel like I can see that one maybe a little bit better than the others. The bottom, we can see that part of it's that dotted line, right? It's this rectangle on the bottom here. I'm going to trace it in blue so that you can kind of see where this is. Okay, now what are its length and width? That would be 16 and 9. So I'm going to multiply 16 by 9 to get 144 for the bottom. Now you may think, oh, I don't see any other faces. Well, there has to be one over here on the left side as well. We have to have 2 triangles and 3 rectangles. So this side is probably the most difficult to identify the length and width of because we can't see it very well. Well, the length and width of a rectangle are always forming this L shape, right? They're the 2 sides that form this L shape. So if I think about this side over here, I know that this side of my triangle, that is one of the sides of that rectangle. And I know that this side is forming an L shape with that here and here. Just like how I have these two being length and width of this, I have these two being length and width of the other side. Now this side is 10 meters. This side, while it's not labeled, if we look across, we can see that it's 9 meters. So the length and width of this other side are 10 and 9. So in this case, it actually did happen to be the same as one of the other sides, but that doesn't always happen. So we just want to be careful and not assume that that's going to happen. So I have the areas of all of my faces. To then get the surface area, I find the sum of them. I add them all together, and I end up with 420 meters squared. Remember, it's surface area, so we do need to label it with meters, or whatever our units are, squared.